Today's lesson is 1.7, representing functions as graphs. So we talked about what it means to be a function. It's one-to-one, meaning every x value has one distinct y value. All right, well now we're going to go ahead and graph these and see what they actually look like. So right off the bat, we have an example, and we have our table. And in our table, we have the x columns, and we have the y columns, okay? In this case, all we're going to do is we're simply just going to plot the points. Each value in the table is an ordered pair, right? So that would be 1, 2, 2, 3, and 4, 5, okay? It's hard to see here, but the graph is labeled for us by ones. So our first point is 1, 2, so the x movement is the horizontal movement. All right, so we're going to do over 1, up 2, and put a dot there. The second point is 2, 3, and the last one is 4, 5. So this is kind of just plotting points, getting a feel for it, and graphing our function that way. Okay. On your next example, it gets a little bit more challenging. It says here that we want to graph the function y equals 1/2 x with the domain 0, 2, 4, 6, and 8. All right, now on this, I'm going to actually change the label of our graph here. I'm going to make them go up by 2's. This way, everything fits. All right, so what I'm going to do is I'm going to make a table, or at least half of it. I have my x column, and that column is given to me. Zero, 2, 4, 6, 8. That was the domain. They gave that to me. Now I need to figure out what the value is when I plug these values into this equation, and I get my y values, my range. So if I put 0 into this equation, I get 0. 1/2 times 0 is 0. When I put 2 into the equation, half of 2 is 1. If I put 4 in here, half of 4 is 2. If I put 6 in here, half of 6 is 3. And 8, half of 8 gives me 4. So now I've completed my table. Okay, so now I know that I have my domain values and I have now my range or my y values. So if I go to plot my points, the first point I'm going to plot is going to be 0, 0, which is right at the origin or the bottom left corner of this graph. The next point I have is 2, 1. So I'm going to go over 2 and up 1, which is half a block because I'm counting by 2's. All right, the next point is 4, 2, 6, 3, 8, 4. All right, and I've plotted all of my points there. Okay, so I graphed the function y equals 1/2 x. All right, on your own, I would take a minute and try this next example. So I'd pause the video, take a shot at it, and check your work with me when you're finished. So hopefully you got a chance to take a look at that. So the first thing you're going to do is you're going to want to make a table, or at least the domain part of it, the x portion of it. And let's fill in our numbers. 1, 2, 3, 4, 5. All right, now let's apply the rule of the function to my domain. So if I plug 1 into this equation, 2 times 1 is 2, minus 1 is 1. If I plug 2 into here, 2 times 2 is 4. 4 minus 1 is 3. If I plug 3 in, 2 times 3 is 6, minus 1 is 5. If I plug 4 into here, 2 times 4 is 8, minus 1 is 7. Then plug 5 into there. 2 times 5 is 10, minus 1 is 9. All right, so now let's go ahead and plot our points. We don't need to change the scale here. Everything will, everything will fit except for the last couple, but that's okay. So we plot our first point as 1, 1, 2, 3, 3, 5, 4, 7 would be here-ish, and then 5, 9 would be up here somewhere, okay? But again, the hard part, or the important part, is that we can generate this table, and then I think you can plot points no problem. All right, moving on here, a little bit of a word problem. It says the table shows the average scores on a mathematics section of the SAT in the United States from 1997 to 2003 as a function of the time t in years since 1997. In the table, 0 corresponds to the year 1997. 1 corresponds to 1998, and so on. Graph the function. All right. Well, before we do all that, it's important that we know when you have a scale like this, or we need to set this up. So we have 0, 1, 2, 3, 4, 5, 6. So the x-axis, so this is my x, and then the scores will be my y. The x-axis is okay, right? 0, 1, 2, 3, 4, 5, 6. The issue, however, is the y-axis. So if you ever see a graph and this line is like kind of broken, I guess, it's kind of jagged, that means you're going from 0 and you're jumping up very high to a different value. So it's saying that this step is not consistent with the increments of the rest of these grids. Okay, that's just something that you'll see a lot in textbooks and things like that. So we're going to actually scale this 510, and then we're going to skip a step and hop up to 514, skip a step, hop up to 518. All right, everything down here is good. So all we were asked to do is just simply graph the function. So the first function the first point we can graph is 0, 511. Well, if this is 0 on my x-axis, if this is 510, that would make this 512. So 511 is kind of right in the middle here. All right, the next one is 1, 512, which would be this crosshair 2, 511. So again, that's like halfway in between. 3 and 514. 4 and 514. 5, 516. And 6, 519, which would not be that high. It would be about halfway there. All right. So hopefully you're able to get this. Understanding that, and then you can plot your points again, no problem. Kind of reading your scale accordingly. All right. For this next example, there was supposed to be a points plotted for you. So it says to write a rule for the function represented by the graph. Well, here's where your points should have been. All right, your points should have been printed to you from 1. So at point 1, 2, at point 2, 3 at 0.34, at 0.45, and at 0.56. That's where your points should have been. They should have been given to you there. Okay, and I goofed when I printed this. So these were given, and they're asking you to write the rule for the function. So what I would do first is I would make a table. This is going to help me see the pattern here. So your table, your x values are 1, 2, 3, 4, and 5. Okay, now the y values, when x is at 1, your y value is at 2. When x is at 2, your y value is at 3. When your x value is 3, your y value is 4. 4 to 5, 5, 6. So there's your table. From your table now you should see when you got to write a function. Well, first of all, let's identify the domain and range. All these values, I should do this in the same color, all these values are your domain. All of these values are your range. Range is always y, domain is always x. Okay? Now, write the rule. Well, we know it's going to be y equals, and the rule has to be what's being done to x to give me y. So 1 to 2, you're increasing, so it's either add or multiply. If I add 1, I get 2. To go from 2 to 3, when I add 1, I get 3. Add 1, I get 4. Add 1, I get 5. So it appears the function is whatever the x value input is, you add 1 to it, and you get y in exchange. So your rule for this is y equals x plus 1. All right, on your own, take a minute and try and identify the two functions for both of these graphs here, and then we will go over it. All right, so after you made your attempt, let's take a look at the first one. So what I would recommend you do for both of these is make a table. Okay, so if we make a table here, you got to be careful because this is kind of hard to see. So at this point, you have an x value at 0, you have an x value at 1, 2, 3, and 4. When the x value is at 0, your y value is at 5. When your x value is at 1, your y value is 4. 2, it's 3. 3, it's 2. And at 4, it is 1. Okay, now this one's tough. For you to see what's going on here, you have to identify that the function is decreasing. Okay, I know that for the main fact that my y's are getting smaller as you travel down this chart that you made, the table, the y values are decreasing, so the function is decreasing. So you're thinking probably add or subtract. Or I'm sorry, subtract or divide. Well, if you put 0 into the function, you could add 5 to get 5. That's really the only way you could go about that. But then if I put 1 in the function and add 5, that would not give me 4, so that's out. So I know it's y equals something. add 5, add 3, add 1, but now you get down here, you would subtract 1 from 3 to get 2. So then you have to start thinking, I'm not really doing a consistent adding, or I'm not consistently subtracting something. I'm not dividing anything, and I can't be multiplying anything, because if I multiply anything by 0, I would have to have 0 on the other side of here. So now I have to really kind of get creative here. So what I would start to think is, what if I combine like a multiplication and addition? So what if I took a number, made it negative, and added to it? So for example, if I took a negative 1 and multiplied it by 0, that would give me 0. And then plus 5, I get 5. Okay, that works for the first one, but let's see if it works for the second one. So take your negative 1, multiply it by 1. That gives me negative 1 plus 5 gives me 4. 2 for 2. If I take negative 2, or I'm sorry, not negative 2. If I take my negative 1, multiply it by 2, that gives me negative 2 plus 5, that gives me 3. So there's your function, right? So this one was kind of tough. You had identified it's decreasing, so you're probably thinking subtracting or division, but then when you try and apply subtracting and division, you find out you need to do 2 steps. Okay? You need to multiply by negative 1 and then add your 5. If I finish these last two, if I take negative 1 times 3, I get negative 3 plus 5 gives me 2. And if I take negative 1 and multiply it by 4 and add 5 to it, well, that gives me 1. So your function is y equals negative 1x plus 5. Okay, that one was no doubt a tough one. If you didn't get that right away, I wouldn't be too panicked. It just takes a little bit of practice. And you can kind of cheat too. I mean, if you look at the graph, you know, if you're strong on graphing lines, you could figure that out pretty quickly using rise over run, those kind of things. But if not, you just have to look at the table and try and pick up a pattern here. All right, for your next one, let's do the same thing. Now this one is increasing. I can tell that because as I travel along the x-axis, the y values appear to be increasing. They're getting higher. Okay, so if I make a table here, x and y. Now again, you're counting by ones on the x-axis. So all the x values I have here, 1, 2, 3, and 4. 1, 2, 3, 4. Those are all the x values I have. The y values are increasing by 5s, right? Each block is 5 units, right? From here to here is 5. From here to here is 10, 15, 20, 25, and 30. So when I have a value of 1, the output is 10. If I have the value of 2, the output is 15. If I put 3 into the function, I get 20 in return. If I put 4, I get 25. Now, this is increasing, so most likely you're adding or multiplying the x value to get your y value. So for me to go from 1 to 10 adding, I would add 9. For me to go to 2 to 15 adding, I would add 13. For me to go from 3 to 20, I would add 17. Then I would add 21. So it's not too consistent of a pattern. But the other thing I know is if I use multiplication, 10 times 1 is 10, 10 times 2 is 20. If I were to minus 5 from that, I would get 15. If I take 10 times 3, I would get 30. Minus 5 from that, that would not give me 20, though it would give me 25. So that's no good, but I'm getting closer. So what if I multiply this value by 5 and then add 5? So 1 times 5 is 5, plus 5 is 10. Okay? 2 plus 5 is 10, plus 5 is 15. 3 times 5 is 15, plus 5 is 20. 4 times 5 is 20, plus 5 is 25. So that seems to be working. So it is 5x plus 5. So take whatever your input value is for x, multiply it by 5, and then add 5 to it, and that is the pattern of this function. All right, again, these are tougher, require a little bit more school of thought. If you're struggling with this, that's okay. Just keep in mind that really just practice is what's going to get you better at this. All right, your last example here. It says the graph shows guitar sales for a chain of music stores for the period of 1999 to 2005. Identify the independent and dependent variable. Describe how sales change over the period and how you would expect sales in 2006 to compare to 2005. All right, just a word of advice here. Typically, when you give when you're given word problems like this isn't always true, but often X is typically your time element. Now, the other way you can identify your independent variable is it's always the X, and this is always your X-axis. So time is your independent variable. That means that the Y is your independent variable. Okay, so your independent variable is years since 99, and your dependent variable is the sales. This is independent, dependent variable. Okay, and I've identified the independent, dependent variable. Describe how sales change, and think about it. You know, the sales depend on the year. This is one of a harder one to kind of explain, but without getting into too much of the economics, the fiscal year, the health of the economy in the year would dictate. Often with sales, if you have a poor economy, people aren't going to be out buying things. So that's kind of the stretch, but that's kind of how you can think of it in terms of, this is what you have control over, and this is dependent on that. But like I said, I would say 85 to 90% of the time in a word problem, X is typically the time element if it's provided for you. Okay, so the second part is to describe how the sales change over the period and how you'd expect the sales to compare in 06 to 05. Well, I think we would all agree, and this kind of goes back to your ability to read a graph, right? As the time element goes on, your Y values are increasing. That tells me that the function is positive, it's going up. All right, that's a good trend. So when I want to describe how sales change over the period, they've increased, right? Every year after 09, they've done better and better and better and better and better in sales. Okay, so that's your answer. Describe how the sales have changed over the period. Well, they've increased. They've steadily increased. Okay. Almost, almost the exact same amount each year. Very, very, very consistent increase. All right. And then it says, how would you expect the sales in '06 to be in '05? Well, I would definitely think they're going to increase. I don't see any sign that it's gonna do this. Could it? Sure, it could, but I don't see any evidence of that. Right? I would assume that the sales in '06 are going to be better than they were in '05. Okay. So I'm not going to write all that out to save space, but when I have to describe how sales have changed over the period, they've certainly increased. It looks like a very healthy, steady increase. All right. And if I want to compare how I think it's going to be in '06 compared to '05, I would have to say I think it's going to be better than it was in '05. It's going to continue to increase. All right. Um, the homework is 1.7 workbook page. It'll be titled um, today's date. So make sure you get that done, turned in. Otherwise, have a wonderful rest of your day, and I'll see you later.